Okay, so we will talk about today the last type of operators that is called as bitwise operators. Okay, bitwise operators, and here, okay, so I told you bitwise operators works on the bits. That means you have to convert number into binary number and then work on it. Okay, so you will have AND operator. Okay, but the AND operator that you have here, okay, works on the bit. For example, if I say num1 equal to say 50 and num2 equal to 25. Okay. Now, what is the binary equivalent of this? You have to convert binary equivalent of this, right? So I'm going to say print bin of 50. Okay. And you have bin of 25. Right? So this will give us binary equivalent of 50 and 25. So here you have, this is the binary equivalent, right? This is your 50. So it is actually 110010. And 25 is, now what I'll do is, I will make it as same number of characters. So I have to add 0, right? So now they are same number of characters. So you have about 6 characters in both 50 and 25. Okay. So 110010 and 011001. This is 25. So when I say bitwise and bitwise OR, okay, it actually works on the bits. So for example, and do it here. So this is your, now if I perform and here, okay, let me go to the next line. If I perform and here, okay, it works on the bit, right? So what is 1 and 0? 0. What is 1 and 1? 1. What is 0 and 1? 0. What is 0 and 0? 0. What is 1 and 0? 0. What is 0 and 1? 0. So output is, okay, 0, 1, 0, 0, 0, 0. This is the AND output. If you want to perform OR output, 1, 0, 1, 1, 1, 1, 0, 1, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1. This is your OR output. Now you want to know what's the value of this? You convert this into integer. So I'll say int of 0 small b and this value. Okay. Similarly, I'll say print 0b this value. Right? 0 we can delete it. So this is bitwise and result. And this is a bitwise OR result. So see 5916. 5916. So this I showed you manually, but how does it work actually? You say print 50 and 25. 50 ampersand 25. 50 pipe 25. You see? And give you 16. So this is how actually it works bitwise. Okay. Okay. Second set of operators that we have in bitwise and which is more useful is called your left shift and right shift. Okay. Left shift means you're saying we'll take same 50 example. Now this is your, where is 50? Yeah, this is your 50, right? I'll say left shift. Left shift, okay? Now, means I'm saying, okay, so you have, let's say you have students sitting in front of you in the chair in classroom setup, and you say everybody turn towards left. Then what happens? Right side, rightmost side, there will be empty space, correct? Correct? So in this case, this one will go to next place. So this is 6, right? So 1 will go to 7th place. This 1 will go to 6th place. 0 will go to 5th place, 4th place. This 0 will go to next place. That means if I say left shift 1, that means I'm saying move to the left 1 place. Then you will get 1 1 0 0 1 0 0. Right side, there will be one extra space. If I say 2, go left 2 times, then there will be one more 0 here. 2 space will be left. So this is your left shift. Now, when I talk about right shift, you are saying move to the right. Now, when you say right shift, okay, now right shift, what happens? This is the last element. So element will start falling down. 0 will go off. So what is left? So this 0 obviously not there. This is the decimal point, correct? So decimal point 0 will go to the right side. So 0 will go off. This is your output. Now let's take example of your integer value, okay, decimal value. Okay. If I say 539, okay, 539, go right. 539 will go right. That means if they are dividing by 10 basically. So what happens? 9 will go off. You have only 53 left. Unit place will go off. If I say one more time, go right. So your 3 will go. You will have only 5 left. Now, other way, if you say left shift, 539, left shift, 0 will get added. So it becomes 5,390. One more time. So if you're doing left shift, right shift in integer, your value is getting multiplied by 10 or divided by 10. So if you do it in binary system, your value will be multiplied by 2 or divided by 2. Right? So let's see an example here. We'll take 50, okay? Same value, right? So if I say here print 50 left shift 2, that means I'm saying 50 into 2 into 2. Okay? What shall we get? 200. Okay? How do you know it is 200? Because 110010, we are saying add one more 0, add one more 0. So it becomes 11001000. Print int of 0b 11001000. This is your 2 times left shift, 200. When I say right shift, 50 greater than 2. So it becomes 50 divided by 2 divided by 2. 50 divided by 2 is 25. 25 divided by 2 is 12. No decimal point here, right? So it should give you 12. You run it, got 12. And you can do it like this. So this is your original 50. I'm saying right shift. So first this will go, second time this will go. So now you see it is 12. So these are your bitwise operators, okay? At least for data analysis kind of work, we don't need it, but yeah, they have their own usage. They are important in their own way. They are important. Okay. So with that, we complete level 1 of programming. Okay. Now we move to level 2. Okay. Okay. We have not done input so far. Okay. So let's do input, and that will complete level 1 of our programming. Okay. So this is bitwise operator. I'll move this to next slide, and then we'll work here. Okay. So next one is input function. Input function is to read values from the user. So far, what we did, we gave our own set of values, isn't it? We said value 1 equal to num1 equal to a equal to x equal to. So we were using our own set of values. But now we want user to give us the value. We want user to give us the value. So how does it work? Simply you say a equal to input. Now input may not take any parameter, at max it takes one parameter. Not like print. Print you can give anything, right? Comma, comma. You can say comma and you can give multiple values, but not in input. Input will not take multiple parameters. So why do we need to give? Okay, so let's say I print here A. So when you run this program, it says A equal to input. That means input will take the value from you and assign it to A. Now see, there is nothing displayed here. But did we get program exited with code 0? No. That means program is still running. Okay. Our program is still running. Our program has not ended. Our program has not ended. It is still running. Then why is it waiting? It is waiting for us to give the value for input. It is waiting for us to give values for input. Okay, because we have not given values for input, it is waiting for us to give value. Okay. So if I give 5, hit enter. You see, 5 is displayed here because we said print A. A took value 5. So you can get confused, isn't it? Right? That, let's say I have written the program, so I know that, I have put input, I need to enter value for A. But if somebody else has written, right, and user is entering, let's say you're trying to book a train ticket or bus ticket or airline ticket. You don't know what to enter here, right? Should you enter name or date of journey or destination? What should we enter? We don't know. So in this case, what we do is, in input, we put our text message. This is called as prompt. Okay, or simply can think of prompt as a helpful text. Okay, so I'll say here, enter the value for length. Okay, and now when I run it, enter the value for length, I say 34. 34. Correct? So now you know at least that, okay, I need to enter the value for length. Okay. Now what's the problem here? Or is there any problem at all? The answer is yes, there is a problem. Why? print type of A. This is the data type of A. Now when I run it, I say 34. It is 34, but see what type of value it is showing us? It is showing us as string, right? It is showing us as string. Should it be string? No, it should not be string, correct? It shouldn't be string. It's a number. Okay. The problem here is Python doesn't know what kind of value you want to enter, right? It doesn't know what kind of value. Do you want to enter integer, float, string? It doesn't know. How can Python predict what value you want to enter? No, right? So what Python says, everything can be converted into string. So reading input value as string is the safe bet for Python. It says, okay, by default, I will read every value as integer. Okay. And if you want it to be, no, sorry, what did I say? By default, I will read every value as string. By default, I will read every value as string, whether it is Boolean, whether it is integer, whether it is float, complex, I will read as string only. And if it is not string, if you do not expect the value to be string, then you convert into the format that you want to. So here, as a user, I'm expecting the value to be integer, correct? It says, okay, if it is integer, you convert into integer. I'm expecting it to be float. Oh, you expect it to be float, then you convert into float. So what I'll do here is, I'm going to convert, so I'll say a equal to int of. So you have functions like int function, string function. So if you want to convert something into int, you convert into int. If you want to convert something into float, you convert into float. If you want to convert something into string, you convert into str of, complex of. So you have functions with the same name. Okay, you have integer function with same int name to convert it to integer. You want to convert it to float, you say float of. Convert it to string, let's say you have integer, but you want to convert now into string. You say str of. So to convert into complex value, say complex of. Convert into bool value, say bool of. Okay, you can convert values into one form to another without any problem. When I say without any problem, it means that if it is convertible, only then. If it is not convertible, then you can't convert. For example, same thing, okay, enter the value of length, I say 10. Can you convert 10 into integer? Obviously, no, right? Because only numbers can be converted into integer, not text. So if it is text, then you can't convert. We will see later how to handle, okay? You can handle using string properties, or you can handle using exception handling. But here, if you do not handle it properly, if I give numbers, then it's fine. And now here I have converted into type string, I'm sorry, converted into here, right? So line number 5, I've converted into integer. Okay, now if you want to print the type, second type if you print, it becomes integer. Okay, now if I want to find area of a rectangle, right? So I can say enter value of length and I'm converting a into int a. Now I can say b equal to input, enter the value for breadth. Now you see, I can second do this, and then I can say b equal to int of b, or I can directly say here itself, int of input. That means, so now you see there are two functions, int and input. What? What I'm doing here, I am calling two functions together. And when you have two functions to call together, first the innermost function is executed. First, the innermost function. So if you have int and input, which will be called first? Input will be called first. Innermost. Then next outer. Finally outermost. So here anyway we have only two, innermost and outermost. So first innermost function will be called, and then the outer int will be called. Okay, so first innermost is called input, so to get the value, and then convert that into int using integer function. Okay, so now I can simply calculate area equal to a into b, and then I can say print area of the rectangle is, you say, area. Enter the length 5, breadth 5, you get 5 into 5, 25. Okay, so this is how we use input to read the value from the user. We'll stop here for today. Next class, we will talk about conditions, if condition. We'll meet tomorrow itself. Most of the people are not there, so we'll have a short session. But good that we started, okay? I don't want to break that chain.